Here we have a problem on integration. That is, we have to find the indefinite integral over here. Okay, let me start working on this. Okay, what I'm going to do is I'm going to make this numerator as 1 and I'll write this secant square x along with dx over here. Then I'm getting 1 over square root of, let me write this 16 as 4 square and this tangent square x as tangent x, the whole square. Then we have over here secant square x times dx. Okay, if we consider the function we have inside the integral, particularly this particular part, that is tangent x. What is the derivative of tangent x? If the derivative of tangent x is secant square x, it is multiplied over here. In integration, whenever the derivative of a part of the function is multiplied in the function itself, what we can do is we can integrate such a function with u substitution. And we have to substitute variable u for the part for which we have the derivative. Here we have derivative of tangent x over here. So now we have to substitute a new variable for this tangent x. Okay, now let me continue with u substitution. That is let u equals to tangent x. Okay, here I have substituted a new variable u for tangent x. Since I have substituted a new variable u for tangent x, I have to get the complete integration in terms of the new variable u. When I get the complete integration in terms of the new variable u, at the place of dx, I must have du, so that I'll be able to integrate with respect to u. If I want to get du at the place of dx, what should I do with this u over here? I have to find the derivative. Since I have the original integration with respect to the variable x, now what I have to do is I have to find derivative on both sides of this equation with respect to x. When I find derivative of this u with respect to x, I'm getting du over dx. And when you find the derivative of this tangent x, it will be secant square x. Okay, now to solve for du in this equation, I have to get rid of the dx in denominator over here. For that, I multiply both sides by dx. Then this dx will cancel out. I'm getting du equals to secant square x times dx. Okay, now let me continue with the integration over here. So that is integral 1 over square root of 4 square negative. For this tangent x, we can substitute the new variable u. Then you'll be getting u square times for this secant square x dx, we can substitute du. Okay, du over here. Okay, now let me consider the formula in integration. That is integral, let me write it over here. Integral 1 over square root of a square negative x square dx. So whenever we have a function in this form, 1 over square root of a square negative x square, so where a is a constant and x is a variable. So the formula to get integration of this kind of function is 1 over a times arc tangent x over a positive c. This is the formula we have to get integration of the function in this form. Now let me consider the function we have over here. It's exactly in this form. So that is the place of a, we have 4. At the place of x, we have u. So in this formula, we have to plug in 4 for a and u for x. Okay, now let me continue over here. So 1 over a. For a, we can take 4 times arc tangent u over 4. That is for x, I just plug in u, and for a, I plug in 4 positive. So constant of integration c. Actually, the given integral is indefinite integral. Whenever we evaluate indefinite integral, we must add the constant of integration according to the instruction we have in the question. That is, we have to use c as a constant of integration. Since I have evaluated the indefinite integral over here in this step, I added the constant of integration c. Actually, in this step, if I consider this particular part, that is u is the variable taken by us. It has to be replaced by the original stuff tan x. Okay, let me do it. 1/4 times arc tangent of. So here instead of u, we can plug in tangent x over 4 positive c. So this is the result of the given indefinite integral.